ready? Order Bruce, here we go. Yeah, it's the starting for Mario. Alright, I don't know if that was intentional, but that's what happened. Alright, so write each fraction. Ratios and proportions are pretty much fractions, okay? So write each fraction in simplest form. So 14 over 16, Taylor, what is that going to be? 7 over 8. How'd you get there? Divided by 2 over 2, right? So we can reduce them. Is 7/8 the same as 14 over 16? Somebody? Yes. All right, I had a bunch of shaking heads. All right, what about the next one here? You want to do this one, it looked like?
2 over...
Michaela, go ahead.
2 over 8.
3 over 8? All right, and how'd you get there? Dividing 8 over 8? All right. So, figure out we divide that same number on top and bottom because that's just a fancy... The 6th grade is fighting me on that. I'm like having to bring in the clubs and different things to try to beat it into them. All right, 9 and 72. What does that go to, Trentone? 3 over 24, and let's go a little bit further, Trentone. 1 over 8.
Yep.
Very good and very good. All right, and 45 over 120. You can divide by 5, I agree. So that gets us to
8 over
9. So 5, that would be 2. 22?
I think.
Think. How are we looking there? And we did that all by division, right? Oh, 3/8. So it must not have been that. It should have been 24. Yeah, because that would have gone 20 and then 3/8. Okay, I did that math wrong. All right. But ratios are literally fractions. All right, and we're going to use these fractions, and we're going to use the. All right. All right, good. All right, we're going to use these fractions to try to figure out problems and solve them. But we got to understand why they go together, and the way they go together is important. All right, stand up and out of the hood. Stand up. Okay, what's your height?
I don't know.
All right, that's a good start. What's your height?
7 foot, no,
4'9", all right?
No, 4'10", 4'10".
4'10", all right, very good, very good. All right, make sure we get that in there. So that his 58 inches. All right, we're going to call you 68 inches.
5'8".
All right, 68 inches. Hey, that'd be exactly the same thing. Now, if I do a ratio of, we're going to get you 6 feet apart. All right, so 58, you got to remember that. 68, you got to remember that. All right? If I do a ratio of Lucas's height to Trenton's height, the first one said should be the one on top. So it'd be 68 over 58. That's important because isn't that different than 58 over 68? Order is important. Just wanted you to see that. Thank you. Out the hood and sit down. There you can regard doing that. All right. So, learn to find equivalent ratios to create proportions. Equivalent ones. We can either make them smaller and reduce them, or make them bigger and expand them. A ratio is a comparison of two quantities. 7/5. Does it look like this takes up the same amount of space as 7/5? It's just another way of writing it.
Yeah.
So, instead of having pieces that are bigger and you're getting 5 of them, all right, you're having pieces that are smaller and you're getting 20 of them, right? So, both rectangles have equivalent shaded areas. Ratios that make the same comparison are equivalent ratios. Just like we had 7/8 and 4/16. They're equivalent, it's just when we divide it into 8 pieces, they're bigger pieces and you get 7 of them. When we divide it into 16, they're smaller pieces, you get 14 of them. But those 14 pieces and those 7 pieces end up being the same amount, right? Does that make sense to us? Okay, so equivalent ones. And how do we get equivalent fractions? We either divide by a number over a number, a fancy one, or we multiply by a number over a number, a fancy one, right? Yep, you guys got that. Ratios can be written 3 ways. This is in your book. There's a picture of it. You can use that. 7 to 5, or 68 to 58. 7:5, or 68:58. Or 7 over 5, 68 over 15. We show you all 3 of these ways because people will mention them. But this is the one we will use the most, okay? Especially when we start solving things. So getting them in the correct order is important, okay? Because that'll help us know what's what, and hopefully we'll go on. So find 2 ratios that are equivalent to 9/27ths. Give me one, just shout one out. 9/27ths,
3 over
3 over 9.
3 over 9, 3 ninths,
1 over 3.
1 over 3. All right, those people both went smaller. Let's do someone that goes bigger.
ratio.
27 over 81.
So all they did was divide by 3 over 3, or by 9 over 9, multiply by 3 over 3, multiply by 2 over 2. You guys know how to make these. You may have a bunch of different answers. 18 over 54 would have worked. You went to 27 over 81. You guys know how to get equivalent ratios, right? All right. There we go. 64 over 24. You guys got to be quiet here. Yes, go ahead, Kevin. 4/3. Okay. 4 over 3. Anybody else? Give me another one, Haley. You did divide by 8 over 8. Good job. Good deduction. You don't know how to do it, or you just got put on the spot and was like froze? Okay, there we go. Taylor, how about 16 over 6?
128 over 48.
Ooh, she multiplied by 2 over 2. Do you see that? But you guys know how to do that, right? All right. I divided by 4 over 4 and got 16 over 6.
What if it's improper?
If it's improper,
You just have
with
to go
ratios, we don't have to worry about it. We can't have mixed numbers with ratios, so if it's improper, that's okay. All right? At this point. All right? All right, these, I'm really not going to waste a whole lot of time because you guys know how to do this, right?
Yep.
All right, Bruce, so we went very super quick. You can see we're either multiplying by the same thing or dividing by the same thing over that. All of them are a fancy
1.
1.
Thank you. All right. A proportion is an equation that states that 2 ratios are equivalent. At the center of everything we're going to be doing for chapter 5, all right?
That's a half. 1.
One equal to the other. And what's going to happen most of the times when we have these is they're going to say, oh, darn. You only have 3 of the 4 things that you need. Okay? So they're going to make up a problem like this. All right? So every day when Carson collects the eggs, there is 1 egg for every 2 chickens. Okay? So that's a statement. So if they have 16 eggs, they would have 8 or 16 chickens, they'd have 8 eggs, right? So let's say during the night, before the chickens went there, a dog killed 2 of the chickens. Carson now has 14 chickens. How many eggs is he going to have?
7. He's got a 7.
Oh, he's going to have 7. Because for every 2 chickens, he gets 1 egg. When the number of chickens changes,
Number of eggs.
the number of eggs changes. And the important thing to remember, if I'm talking about chickens on the bottom, what needs to be on the bottom over here? The number of chickens, right? If I'm talking about eggs on top, what needs to be on top? The number of
Eggs.
And it works with conversions as well. And this is where I had great success with them. Trenton walked 10,000 feet. How many miles did Trenton walk? Do you know how many miles Trenton walked? No. We know how many feet he walked. But hold it. Look in the back of your book. Because I'm going to make a proportion.
If you look in the back of your book, it'll say how much feet are in the mile.
Oh, it will. So what should be on top on this side?
In 1 mile, there is 5,280.
But what should be on top on this side?
5,200.
5,280. Because that's the feet, right? And that equals 1 mile. Oh. Now this one was easy. We saw times 7 times 7. But does anybody remember the cross multiply and divide? 5,280x equals 10,000. Oh, 5,280x. What do I need to divide by now in this step? Let's look at the problem.
Did we do this last year?
Yes, we did. A little bit. Do you not remember it this way? If this is an inverse operations problem, what do we need to do? Oh. I divide by 5,280. Somebody with a calculator, get on it. 5,280. All right. And I find that it's
1.89393939. 1.89393939.
and that was miles, right? I'm getting a little bit advanced, okay? We're kind of jumping into other lessons. Oh. But do you see, we had feet over miles because we didn't know the miles, we knew the feet. So on the other side, we do a proportion that's exactly feet over miles. And since it's a proportion, we can do the cross multiplying. Does that make sense? Okay? Just like we did here, if we would have done 2x equals 14, I divide by 2, I get my 7 that goes up there, right? Do you see that? We could see it was times 7 times 7, but if we did cross multiplying, it would work in the same way. We're always going to be setting up, Natalie, 2 ratios that are equivalent. And when we do 2 ratios that are equivalent, that is a proportion. A proportion means we have 2 fractions, and we put them equal to each other because they're equivalent. And usually you have one of those parts missing. Okay, so simplify to tell whether the ratios are a proportion. Now, there's 2 ways we can do this, all right? We can get them down to simplest form, and I can see that, oh, I divide by 3 over 3, that's 1/9. I divide by 2 over 2, that's 1/9. I see that they're equal then, right? If you take them down to simplest form, you'll be able to compare them. Does anybody remember the shortcut way we had?
No. Was it where like you? Oh, butterfly!
Yes, the dreaded butterfly that Mr. Palm cursed about and hated.
I like that.
Okay?
I think
love
it
my
depends. If it's a bigger number, I think multiplying is easier. But if it's a simple number, then it's easier.
Okay. So the 2 things we did, Christine. If you think that they're smaller numbers and they're easy to reduce and get down to simplest form, take them down to simplest form. And if the simplest forms are equal, they're equal. If you use cross products, oh, and the numbers are equal, they're equal. What happens if the numbers aren't equal or the simplest forms aren't equal? Then they're not equal, right? Pretty simple. Looking at this one, who wants to simplify it down to simplest terms for me? Because 15 times 27 in my mind sucks. And 12 times 36 in my mind sucks.
5. What's the cost? 405 and then that's 405. I know it is. Oh.
Well, they're not
15
proportional.
and 12.
Oh. Okay, so that would be divided by 3, that would be 4/5. And that would divide by 9, and divide by 9, that would be 3/4.
4 times 4 is 16. It's not. I don't think it's equal.
Well,
I got confused.
What was 36 times 12?
100, no,
36 times 12 is
405.
432,
Or
The other
32?
one's 405.
and then the other one's like 405 or something.
405. Those are not the same. And if we reduce down to the simplest form, this one changes into 4/5, and that one changes into 3/4. So both ways work. I would rather divide by a 3/3 and a 9/9, but if you want to do the other way, that's fine. Heads down. How do you feel about comparing fractions to see if they're equal? 5 is I got it great, 1 is I don't understand at all. Okay, hands down, heads up. Alright, so we did those. Alright, they're showing reducing. Alright, I like that way. So when we look at this one then. Now, reduce that down for me, Haley. 3/15, what does that become? Okay, what does it come, Lucas?
1/5.
1/5. Now, Haley, what does this one become? Are these equal? And if we use this,
They're equal.
120, and that's 135, and we do this, 90 and 135. Either way works. You just must understand what you're doing. I personally like this one better. But there's nothing wrong with that one. All right. So tell me about B. You can on your paper simply write yes or no.
No.
Lucas says no, okay. How you know no so fast, Lucas?
Because the other one is it's 2 7s,
Okay, so we said this is 2/7.
and then 7 can't go into
There's no way that we can get a 7 when we're working with 36, right? So Lucas figured out real quick, even without taking it down to simplest form, no, that won't work. Now, if I did that, it would be 4/9, and Lucas was exactly right.
And then
Lucas,
the butterfly way, it's
good
like
luck.
504 and then 784.
504, 784. Yeah, it's quite a bit different, isn't it? Okay. So, we're doing that. We're filling these. All right, Michaela, on A on the next page. You're up. Oh, my gracious. Now, this is not A. At 4 degrees, 4 cubic feet of silver has the same mass as 4 cubic feet of water. What? Densities are the same. Okay. At 4 degrees Celsius, would 210 cubic feet of water have the same mass as 20 cubic feet of silver? So let's read the top problem again, or the top sentence. At 4 degrees Celsius, 4 cubic feet of silver has the same mass as 42 cubic feet of water. Did they give us a ratio that we could write from this first sentence? Did they give us a fraction if we stop right there?
Yes.
Yes. What was that? I heard a yes.
4/42.
All right. So 4 cubic feet of silver. Okay. So 4 of silver. And labeling is important to help you know. Over 42 water, right? So, if I have this much silver, 4 cubic feet, it's equal to 42 cubic feet of water. Their weights are equal, all right? So if I put 4 cubic feet of silver on a scale and 42 cubic feet of silver on a scale, they would read the same weight. Do you understand what they're saying? Yep.
We're just trying to see if they're equal.
Now, we're trying to see if they're equal. That is a true statement. Now, what Christine did, she came in with 210 cubic feet of water. Does 210 go on top or bottom, Christine?
On the bottom.
Because it's water, right? And water was on bottom. 210 water. Oh. What goes on top then, Tori? Or Summer?
4 degrees.
4 degrees? No, I'm sorry. Degrees was not on top over here. What was on top over here?
4. Silver.
Silver was on top.
1.
So look at the second one. At 4 degrees Celsius. The 4 is just those math people laughing at us non-math people saying, I'm going to throw extra numbers in there. 210 cubic feet of water. And then Haley came in with 20 cubic feet of silver. You see how we had feet of silver over feet of water? So,
Silver.
feet of water, what needs to go on top then? Why 20? Because it's the 20 for silver, right?
No, they're not.
Alright, yep. So there's that one there too, yeah. They threw them in there. So Lucas says they're not the same. How'd you get to that, Lucas?
Well, with 4 over 12, you get 2 over
21.
Never mind, yes, you're right.
Told you.
Divided by 2, that's 21, right?
Yep.
Alright, divided by 10. That's 2 over 21. Did they end up being the same, everybody? That's simplest form. And if we do our multiplication, Taylor, did they end up being the same? The butterfly method.
Yep.
It did. Now I'm going to ask another question. Let's say that when I started this problem, Michaela, you said, 42 cubic feet of water equals 4 cubic feet of silver. Did she set that ratio up okay? Yeah. Now, the only thing is, when we look at Michaela's, what needs to go on top, Michaela, if you said 42 feet of water over 4 feet of silver? What? What's that?
4 silver is on top.
No. So we've looked at the first sentence, you set this up. Now we look at the second sentence. From the second sentence, what number needs to go on top?
10.
What?
210.
210. Now, hold it. She picked 210 and I agree with her and I like what she did. Why does 210 have to go on top?
Because it's water.
Oh, water was on top over here, right? So water's got to be on top over here. Good job. And then that means that 20 is going to go on bottom because the silver. When I cross multiply, I'm still multiplying the same numbers. When I reduce fractions, I'm still reducing. As long as we stay consistent in the way we set it up, it doesn't matter which way we do it, does it? Okay. Let's go out for mass break. We're going to hit this again tomorrow. Not tomorrow, Friday.